Here's the derivation of the electric field of a long, straight, charged wire. If the wire is lying on the x-axis, and we want to know the electric field at a point, a distance y above the origin, we have to take this as an integral, because we have lots of little bits of charge, and we need to add up all their effects. So to get the electric field in the y direction, we add up all the DEYs. We integrate that. What is the electric field in the y direction? It's the electric field cosine theta. But this is a little bit of the electric field due to a little bit of charge, which is related to a little bit of distance or a little bit of angle. And the charge per length we often call lambda. So dq over dx is lambda, so dq is the same thing as lambda dx. Meanwhile, the electric field of a point charge is kq over r squared. So the infinitesimal electric field of an infinitesimal charge, dE would be k dq over r squared. So to get the y component of that, we have to multiply the dE by the cosine of this angle. And the cosine of this angle can be written in different ways, and one way is y over r. So if we put that in there, that's our expression for dEy. So to get the electric field, we need to integrate that. X can range from minus infinity to infinity. So we have to integrate from minus infinity to infinity this y, k, the little bit of charge is lambda dx, and the r cubed is y squared plus x squared to the 3/2. That was all the physics. The rest is calculus. It's written here on the board, and the final answer is electric field y is 2 times k times lambda over y.